In this section, we're going to take a look to the switched networks overview. If you want to manage a switch remotely, you should assign an IP address and default gateway to the device. Management IP and default gateway is configured on switch for remote access. If you want to assign an IP address to a layer 2 switch, you should assign it to the VLAN, not a physical interface. As you can see in here, we are getting into the interface mode by typing interface and the VLAN number. Then we are assigning our IP address by using the IP address that we want to configure and the subnet mask command. The default gateway configuration is also pretty straightforward. To configure a default gateway on a switch, our command is IP default gateway and the IP address of the default gateway. Let's go ahead with how to configure a switch port now. To configure a switch port, we should go to the interface mode by typing interface and the interface name on the config mode. In this example, we are defining the speed of the port and we are defining a full duplex option for the related interface. Let's take a look to the configuration now. The interface name is Fast Ethernet 01, as you can see, and I'm getting into the interface mode by typing interface and the name of the interface. As you can see, as soon as I type the enter, as soon as I hit the enter key, I'm anymore in the config AF. I'm in the config interface mode, and to define a duplex, I'm typing duplex and the duplex speed, and to define a speed for the port, I'm typing the speed and the speed that I want command. To verify the switch port configuration, we can use show run interface and the interface name as the first option. This command shows us the whole configuration of the related interface. For example, in here we are typing a show run interface Fast Ethernet 01, and here is the whole configuration of the Fast Ethernet 01, as you can see. The second option for verifying switch port configuration is show IP interface brief command. This command shows the physical status of the interfaces, and if this is a layer 3 capability switch, this command also shows the IP addresses assigned for the interfaces. For example, as you can see in here, on switch 1 we are typing a show IP interface brief command, and we can see the physical status of the ports in here, and as you can see, some ports are in up mode, some of them are in administratively down mode, and we can see the IP addresses assigned to switch ports because this is a layer 3 capability switch. The third option to verify the switch port configuration is the show interfaces and the interface name command. This command shows the physical status of the interface, such as if this is up or down or something like that, and this command also shows some useful information such as MTU, bandwidth, delay, if we have some input errors or not, or if we have some CRCs or something like that. We can monitor all of them with this command. Let's take a look to the switch security now. As we talked before, we should always use SSH instead of Telnet because SSH encrypts the whole connection. To configure the SSH as a remote connection protocol on a switch, our command is crypto key generate RSA general keys modulus and 1024. But first, we should create a domain name to activate SSH on our device. Here is the domain name configuration, IP domain name, and we are typing a arbitrary domain name. Then to generate the crypto keys, we are typing the crypto key generate RSA general keys modulus and the key modulus size, which is 1024 bits for this example. Let's take a look to the local area network attack types now. Without security measures and controls in place, your network might be subjected to an attack. Some attacks are passive, meaning information is monitored. Others are active, meaning the information is altered with intent to corrupt or destroy the data or the network itself. Your networks and data are vulnerable to any of the following types of attacks, such as MAC flooding, DHCP spoofing, telnet attacks, and the CDP attacks. If you do not have a security plan in place, you may face with all of these attack types. Let's start with the MAC flooding first. In computer networking, a MAC flooding is a technique employed to compromise the security of network switches. The attack works by forcing legitimate MAC table contents out of the switch and forcing a unicast flooding behavior, potentially sending sensitive information of portions of the network where it is not normally intended to go. Switches maintain a MAC table that maps individual MAC addresses on the network to the physical ports on the switch, as you know, and this allows the switch to direct data out of physical port where the recipient is located, as opposed to indiscriminately broadcasting the data out all of its ports as an Ethernet hub does. In a typical MAC flooding attack, a switch is fed many Ethernet frames, each containing different source MAC addresses by the attacker. The intention is to consume the limited memory set aside in the switch to store the MAC address table. As you can see in here, we have an attacker, and our attacker floods CAN table with frames with numerous invalid source MAC addresses, and valid hosts cannot create CAN entries anymore. Then in the second step, normal traffic is flooded out all of its ports because no CAN entries exist for the valid hosts. Let's take a look to the DHCP spoofing now. This is a special kind of attack where attacker can gain access to network traffic by spoofing responses that would be sent by a valid DHCP server. Client PC is sending DHCP requests on the network. This request is a broadcast and all hosts on the local area network will receive it, as you know, guys. Only DHCP server knows what this request means actually, and in the normal situation only, the real DHCP server will reply that request. DHCP server is then replying the client with message that will configure the host client PC with IP address, subname mask, and the default gateway. When we have attacker PC in the network, he will simulate DHCP server on his host PC. With this action, he will be able to reply to the DHCP request before the real DHCP server because it's closer to the client host. It will configure the client host with IP address of that subnet, but it will also give to host false default gateway address and maybe even false DNS server address. DNS server and default gateway address will both be IP address of attacker's computer. In this manner, he will point all the communication of the client host to himself. Later, he will make possible to forward frames from client host to real destinations in order to make communication of client possible. client will not know that his communication is always going to attacker PC and that attacker can easily sniff frames. To mitigate this attack, we can use DHCP snooping method, which we are gonna see on our later slides. And let's go ahead with the telnet issues. We talked a lot about this thing, as you know, and as we talked before, telnet is an unsecure remote connection protocol because it does not encrypt the communication. Telnet can also be used as a part of the DDoS attacks, and because of this, we should always use SSH instead of telnet. And let's go ahead how we can secure our switch ports. To secure out switch ports, which means their interfaces, we have three options. First, we should shut down our unused ports. Second, we should use DHCP snooping. And third, we should use port security. If we are not using a physical port, we should always shut down it manually because of mitigating the physical layer attacks. Unused ports always must be kept shut down. So, to configure a manual shutdown, we are getting into the interface mode again. Interface and the interface name that we want to shut down. And the command is pretty straightforward. We are using shutdown command and we are administratively shutdowning the port. And let's go ahead with the DHCP snooping. In computer networking, DHCP snooping is a series of techniques applied to improve the security of a DHCP infrastructure. When DHCP servers are allocating IP addresses to the clients on the local area network, DHCP snooping can be configured on a local area network switch to prevent malicious or malformed DHCP traffic or rogue DHCP servers. In addition, information on hosts which have successfully completed a DHCP transaction is accrued in a database of bindings, which may then be used by other security or accounting features. So let's go ahead how we can configure a DHCP snooping now. To configure a DHCP snooping, we are getting into the config mode. Then first we are globally enabling the DHCP snooping by typing IP DHCP snooping command. The second thing we are gonna do is we are typing IP DHCP snooping VLAN and we are defining the VLAN numbers that we are gonna use for the DHCP snooping. In the third step, we are enabling DHCP option 83 by typing IP DHCP snooping information option. Then we are defining the number of acceptable DHCP packet per second for switch ports by typing IP DHCP snooping limit rate and the rate that we want. Then in the last step, we are defining DHCP trusted ports. IP DHCP snooping trust is the command that we are using for this. Please keep in mind that for trunk ports and DHCP server ports, we should define this command. Let's go ahead with the port security now. You can use port security feature to restrict input to an interface by limiting and identifying the MAC addresses of the workstations that are allowed to access port. If a port is configured as a secure port and the maximum number of secure MAC addresses is reached, when the MAC address of a workstation attempting to access to the port is different from any identified secure MAC addresses, a security violation occurs. And we have 3 violation modes, and they are shutdown, protect, and restrict. So let's take a look to the port security in our slide now. Alright, in here we have a switch port and we have a hub connected to this switch port. As you can see in here, in the hub we have 2 PCs and they are PC1 and PC2, which means we have 2 MAC addresses behind our switch port. If we define a port security for this port of the switch, and if I configure in here with port security of maximum max of 3, for example, and if I plug a PC, which is PC3, and one more PC, which is PC4, that means a port security violation. As I told you, we have 3 port security violation modes and they are shutdown, protect, and restrict. In the shutdown mode, we are blocking all traffic and place the port into error disable mode. We are shutdowning our port, our switch port, if a violation occurs. In the protect, we are blocking the traffic who makes the violation and we are allowing other. That means, for example, in here we are just blocking the traffic of the PC4, but PC1, 2 and 3 still can go ahead. And in the restrict mode we are blocking the traffic who makes the violation and allow other, and this time we are also creating a log message. To configure a port security, we are getting into the interface mode by typing interface and the name of the interface. Then we are typing switch port security and enabling the port security now. But as you can see in here, command is rejected because Fast Ethernet 01 is a dynamic port, which means we need to define a access mode for the switch port that we need to configure the port security. Because of this one, we are typing switch port mode access. Then we are typing the switch port security command. After switch port security maximum, and we are defining the maximum MAC addresses that can be learned from that switch port. And the last step, we are typing switch port security violation, and we are defining a violation mode which is restrict for this example. A port security violation can make our port to an error disable mode. Ports must be reactivated by using shutdown and the no shutdown commands after the device is removed, which makes the violation. We can use the show interfaces status error disabled command to monitor the error disabled ports. For example, let's say that Fast Ethernet 01 got into the error disabled mode. To reactivate this port, we are getting into the config if mode by typing interface Fast Ethernet 01, and we are typing shutdown first. Then we need to type no shutdown to activate it.